Example 8. Evaluate the integral, open bracket 1 over open 1 plus x to the 7th power, close bracket, dx as a power series. B. Use part A to approximate the integral from 0 to 0.5 of open bracket 1 over open 1 plus x to the 7th power, close bracket, dx. Correct within 10 to the negative 7th power. Sidebar. This example demonstrates one way in which power series representations are useful. Integrating 1 over open 1 plus x to the 7th power, close by hand, is incredibly difficult. Different computer algebra systems return different forms of the answer, but they are all extremely complicated. If you have a capital CAS, try it yourself. The infinite series answer that we obtain in example 8a is actually much easier to deal with than the finite answer provided by capital CAS. Solution. A. The first step is to express the integrand, 1 over open 1 plus x to the 7th power, close, as the sum of a power series. As in example 1, we start with equation 1 and replace x by negative x to the 7th power. 1 over 1 plus x to the 7th power equals 1 over 1 minus open negative x to the 7th power, close, equals the sum from n equals 0 to infinity of open negative x to the 7th power, close, to the power n, equals the sum from n equals 0 to infinity of open negative 1 close to the power n times x to the power 7n equals 1 minus x to the 7th plus x to the 14th minus ellipsis. Now we integrate term by term. The integral of 1 over 1 plus x to the 7th power and dx equals the integral of the sum of n equals 0 to infinity of open minus 1 close to the power n times x to the power 7n dx equals big C plus the sum from n equals 0 to infinity open negative 1 close to the power n. We have x to the power 7n plus 1 over 7n plus 1 equals big C plus x minus x to the 8th power over 8 plus x to the 15th power over 15 minus x to the 22nd power over 22 plus and so forth. This series converges for the absolute value of negative x to the power 7 is less than 1. That is for the absolute value of x less than 1. For part B, in applying the fundamental theorem of calculus, it doesn't matter which antiderivative we use. So let's use the antiderivative from part A with big C equals 0. The integral from 0 to 0.5 of 1 over 1 plus x to the 7th power dx equals open bracket x minus x to the 8th power over 8 plus x to the 15th power over 15 minus x to the 22nd power over 22 plus and so forth. Close bracket from 0 to 1/2 equals 1/2 minus 1 over 8 times 2 to the 8th power plus 1 over 15 times 2 to the 15th power minus 1 over 22 times 2 to the 22nd power plus ellipsis plus open -1 close to the power n over open 7n plus 1 close times 2 to the power 7n plus 1. This infinite series is the exact value of the definite integral, but since it is an alternating series, we can approximate the sum using the alternating series estimation theorem. If we stop adding after the term with n equals 3, the error is smaller than the term with n equals 4. 1 over 29 times 2 to the 29th power is approximately equal to 6.4 times 10 to the negative 11th power. So we have the integral of 0 to 0.5 of 1 over 1 plus x to the 7th power dx is approximately equal to 1/2 minus 1 over 8 times 2 to the 8th power plus 1 over 15 times 2 to the 15th power minus 1 over 22 times 2 to the 22nd power, which is approximately equal to 0.4995137